What if you were asked to come up with a polygon that has the same area, even if you change the angles, lengths, and so on and so forth? In this video, I'll be showing you a powerful script which can help you to stabilize the area while changing the size in terms of the length, angles, so on and so forth, so that you can have many variations or iterations of the same goal. So in my Grasshopper screen, what you see, maybe I preview everything off for a second and give you how I start with. So I start with a simple rectangle, and this rectangle is divided and exploded into some lines. Then each line is transferred into a line segment or separate line segment so that we can grab all these four curves, okay, including this one. And what I can do, I can start rotating this one. So I'm rotating this one based on this point. So you see, based on this point, I am rotating this curve, and we could change the rotation point as well. And I'm doing this for all these four. Okay, maybe I then preview them all. And I started to see some kind of adjustments, right? Now they're rotated, but they are not working together. Then I use shift list, connect them together, and find their intersections. And by using those intersections, I get these points and use those points to come up with a polygon. Therefore, whenever I change the angle, you see, I still keep the same thing. Obviously, when I see these components, maybe a little confusing, but when you change the angle, you have the same thing. When you change the rotation kind of plane, you have a different result, and so on and so forth. Then what I did is basically scaling this into the number that I want to scale. So let's say this is the scale, this is the area that I want to have, okay? And then if this is the area that I want to have, I am using scaling component by getting the area of the initial polygon that I created and then scale it down with what I want to have by getting their square roots so that I have this small piece. And then imagine this dashed line is your boundary. What I'm doing here is projecting the area, giving some kind of a line here or colors here. And this is interesting. I'll be talking about this in a second. I'm showing each angle here. Okay, so the text size, sorry, the text is a little small here. Maybe we can put 1.5 here. By the way, if you want to get free access to this Grasshopper definition, join my free school community with the link in description, and you'll get it for free. And I can increase the size of the angle if I want to. We can turn on the dimensions so I know exact dimensions that I have. Obviously, if it's too much, you can make it smaller and so on and so forth. So what this does, basically, it turns this piece into red with this Python component in it, because now there's a collision, right? So my plot or my area is going outside of my plot. So if I make some adjustments, if I change this a little more, maybe a little more of this, it turns into white. And when it turns into white, it means it fits to this. And what I see here in the Python script, it gives me the white color. And also, if it's inside of this boundary, it gives an extrusion to this massing so that you can visualize it easily. By the way, if you're serious learning about Grasshopper, I have 2 spots remaining to work one-on-one with me. Again, if you're serious, book a call with me with the link in description, and we can sit down. I can help you to elevate your career by getting these skills to get a better job or land a job as a computational designer. But within this Python script, what this does, it basically gets the X input as if the X is true, A is going to be Indian red, which is collusion. If there's no collusion, there will be white color. And as a B output, I'll get an extrusion component or extrusion function from Grasshopper. And A output is the color out. And that is it. Thanks for watching this video. If you find this helpful, give me a thumbs up, and I'll see you in the next one.